Imagine AI infrastructure like a delivery service. Compute is the team of delivery drivers, constantly picking up packages and getting them to their destinations. Storage, on the other hand, is the warehouse where all the packages are kept well organized and ready to be loaded onto trucks. Networking is our field, and these are the roads and traffic systems. They ensure the drivers can navigate easily without delays, reaching their drop-off points as fast as possible. If the warehouse isn't stocked or the roads are blocked, the deliveries slow down. But when all parts are working smoothly, deliveries are made efficiently, just like how a well-coordinated traditional AI infrastructure processes and transfers data. In AI infrastructure, hardware, software, and data management are the foundation of everything. Hardware to begin with. It has different components, as you know. It has the CPU, the memory, the RAM, the GPU as well. But hey, there was a shift from central processing unit to GPUs, mainly because of the speed that the GPU can offer. But don't forget, everything comes with a price. The higher the speed, the more the cost and the maintenance value. In the past as well, software was mostly proprietary, designed for specific tasks with simpler algorithms and manual optimization. Whereas for data management, this guy right here, it had its limitations as well, handling smaller data sets with manual processes due to constraints in storage and processing. Nothing like, the vast automated system of today. Moving on to the core components: compute, storage, and network. These hardware components are actually what drive the modern AI infrastructure. If we talk about compute, for example, you know for sure that it's made of different hardware pieces, such as the CPU, the memory, the RAM, the NIC card, and the GPU. Since you said GPU, well, I know that GPU is actually made for gaming and for graphics. But wait, now GPUs power deep learning. They can form different clusters that can scale to support massive AI models. If you want more GPUs, you can have that, because actually in a single compute node, you can have 4, 8, or 16 different GPUs in a single compute node. If you need to transfer the data between those different GPUs, or maybe if you want to transfer the data across different compute nodes, then you need to use the NIC card, of course. NIC cards in modern AI infrastructure, they can give you bandwidth that can go all the way up to 400 gigabit per second, but wait for it. It can also go to 800 gigabit per second. That's the speed that NIC cards can offer you. What else? Well, we need to talk about what fuels these nodes. These compute nodes can be fueled using storage. Okay, when it comes to storage, high throughput, low latency is the key factor for this. And this is what InfiniBand's RDMA is going to give you. Low latency communication, high throughput, less reduced processing with the CPU because the GPU is actually working. Where, on the other hand, SSDs or solid-state drives are favored for their fast read-write speeds and durability, making them ideal for AI applications that require rapid access to large data sets. For environments that require flexibility, you can take the help of this guy, IP-based storage fabrics. What do? They can actually allow for easier integration with existing infrastructure, because you're using the existing infrastructure that you have, which is the IP and Ethernet. On the other hand, if we talk about distributed storage, they give you that flexibility while maintaining resilience necessary for large-scale AI workload. Last but not least, the networking part of it. Networking, which is going to tie everything together. It's going to tie all the pieces together. We're talking here about a bunch of different items. First, we talk about the topology, the architecture that support the AI workload. As you can see here, this is the spine and leaf topology, with spines connected to leaves, leaves connected to spines, and the leaves are also connected to the servers that can connect those different servers together that will enable the low latency communication, which is, again, if we talk about how will this low latency communication be supported by those different switches. Look at that. We support the switches support 400 gigabit per second. Is that it? No, of course not. It can go all the way up to 800 gigabit per second as well. And let's not also forget about the subscription ratio, which is optimum for the low latency that you're looking for. 1-to-1 ratio is optimum, but let's not forget that also 4-to-1 ratio is also supported. Again, that ensures smooth communication for the training cycles or the AI training cycles. Together, compute, storage, and networking mainly form the backbone of a high-performance AI infrastructure capable of handling both small and large-scale tasks. Summary time. In a traditional AI infrastructure, we have multiple components that play major roles altogether: hardware, software, and data management. The hardware is subdivided into compute, storage, and networking. And when it comes to compute, specifically, we have the CPU and the GPU, the NIC card, and many other pieces. However, the GPU and the NIC card are what play major roles. The GPU, in one hand, can be like 4 GPUs, 8 or 16 that can give you optimum speed when it comes to data processing. Whereas if we want to transfer data between different compute nodes, the NIC card within one compute node can reach up to 400 or 800 gigabit per second, altogether connected in a data center that is made of a spine and leaf topology. And on the other hand, let's not forget that the storage has different flavors, such as InfiniBand's RDMA, or maybe SSD, or maybe traditional IP storage, or even the distributed storage. I hope this was informative. I'd like to thank you for viewing.